So far, we have looked at a brief description of each module, how to use set technology, and the difference between a project file created through TSolidX layout and creator. Now, let's set up the simulation conditions in earnest. You can define the structural information in the Stack tab. Add or delete layers using the icons at the bottom. So, to add a layer, click Add button. Enter the name and select material type. In this case, I will enter glass and select insulator. Click OK button. You can see that the glass layer is added. This green icon is called zone condition, and you can define the properties of the layer in detail. I will explain the basic features that you need to know for using the TSolidX program. Let's look at it from the beginning. You can modify the layer name and material type between insulator and metal. And then select the substrate property. If the layer is stacked, select stack. If the layer is a substrate like a glass layer, select substrate. If the material is being filled like LC, select fill. The next one is etch part. If you click the list, there are unselective etch, until zone, and until zone with stopper. And then there is an etch stopper below. Let's see unselective etch and etch stopper first. Unselective etch means that the etching process starts from that layer. Then, etching proceeds until just before the layer for which the etch stopper is checked. To clarify the concept of two functions, let's look at the following example. The etching process starts from layer 3. It means that unselective etch should be checked for the zone condition of layer 3. And when you want to proceed with the etching process from layer 3 to layer 1, layer 0 should be an etch stopper, because etching proceeds until just before the layer for which the etch stopper is checked. Therefore, the result will be generated like this. The next one is until zone. It is convenient to think of until zone function as a slightly more powerful etching process compared to the unselective etch. Even if there is a layer set as an etch stopper between the layers, designated as until zone, etching process is unconditionally performed. This example is easy to understand about unselective etch and until zone. Etch stopper 1 means that etch stopper is checked. So in case of unselective etch, the etching process was performed just before the etch stopper. On the other hand, if this blue layer is selected in the until zone, whether there are etch stopper layers, the etching process proceeds until just before the blue layer. So, that is the difference between unselective etch and until zone. Lastly, until zone with stopper means to perform the until zone process while considering whether to apply the etch stopper. From insulator 1 to insulator 4, etch stopper is unchecked. And there are two types of CNT mask. For the CNT1, select Until Zone with Topper and click Insulator 1 from the list. And when unselected edge is applied to the CNT2, the following structure can be created. Therefore, please note that depending on the desired structure type, etching function should be selected differently. To make it easier to understand, use unselective etch and etch stopper for simple etching. Use Until Zone if you want the layer set as etch stopper to be etched. And if you want to realize the following shape, please utilize Until Zone with stopper. By using overetch thickness, it is possible to generate the structure that is overetched as much as entered thickness. And the next one is chemical-mechanical polishing thickness. Just enter the thickness to proceed with the CMP process. Also, you can define the thickness of the layer. Division is to enter the number of divisions in the z-axis direction. When generating the structure of the sidewall model, please note that there is a difference in structure generation according to the division value. The next one is planarization. To generate the planarized layer, please set to yes. In that case, the degree of planarization and gap position are also activated. This figure shows whether the planarization is used or not. And degree of planarization for the layer varies from the entered value. As an example, when the degree of planarization is close to 1, the structure will be perfectly planarized. On the other hand, when the value is 0, the result is the same as not using this function. The conformer structure is generated. In the gap position, set the position where the planarization option is applied. And there are 4 types: mean, max, relative position, and estimating position. If the gap position is selected as mean or max, the reference zone is activated. Also, when the gap position is set to relative position or estimating position, X and Y are activated. Since usually mean and max options are used, I will mention them in detail. Literally, mean means that defines the thickness based on the minimum position, and max is based on the maximum position. And based on the reference zone layer, the entered thickness is determined. The following example is easy to understand about the concept of the reference zone. At first, let's check the simulation conditions of layer C. The thickness is 1 micrometer. Set DOP as 1 to completely planarize. And gap position is max. On the left, the reference zone of layer C is set to none. And on the right, The reference zone of layer C is set to A. Did you see the difference between the two? Please check the thickness of layer C. If the reference zone is selected as none, the thickness is defined based on the top position of the layer immediately below it. In this case, layer B. For the second one, the thickness is 1 based on the top of the layer A because the reference zone is set to A. The next one is division reference zone. It will be easier to understand by looking at this picture. You can utilize this function when you want to create layer B with completely planarized, that is smaller in thickness than layer A. Additional nodes are inserted into layer A at locations equal to the thickness of layer B. In the patterning property, define the mask of the layer. If the mask is a negative mask, please check it. Choose the sidewall type among 6 taper models. In the taper type, select one between angle and width. Depending on the taper type selection, the input value is set as angle or width for the taper value. The next one is Advanced tab. The Advanced tab is for creating a realistic layer structure. There are a lot of functions including digitize, CD margin, and rounding. Please check the manual for descriptions and usage about advanced and more condition. Now that we know about the zone condition briefly, let's define the stack information of the example. First, add the layers to be used and define the name and type at the bottom. To modify the thickness, just double-click here or click the zone condition and you can change the value. For me, I will just double-click it and change the value. And then let's check the layer at the bottom step by step. The first one is glass. Since it is a bottom substrate, the substrate type should be changed as substrate. And then click OK button. The two buffer layers will be skipped because there is any other modification. The next one is the active layer. First of all, active is the layer to which you need to specify a patterning mask. So select the active mask in the patterning part. Also, if you want to identify this mask layout, please click on the Defining Area tab. There is View Layout. Sometimes some people ask me that the mask design is not visible in the View Layout. In that case, if you click this option and change it to front and back, you will probably see it. So, if you use this view layout, you can check the mask information defined in the layout file and technology file. In the layer list, you can check the layer name according to each layer number. And if you click on the active layer and then make other layers invisible, you can see only active layer. And to briefly explain how to use the layout tool, if you want to zoom in or out, please press Ctrl key and move the mouse wheel. When moving up or down, just move the mouse wheel. And when moving left or right, please press Shift key and move the mouse wheel. To adjust the viewer screen automatically, press Ctrl key and alphabet F key at the same time. Therefore, please make good use of the view layout when you want to check the mask design for each layer as follows. And then, for the intermediate insulator layers, I will skip them for now. Now let's define gate 1 and gate 2. Just select the patterning mask. The next one is CNT. If you check the CNT mask, it is a hole-shaped mask. In order to create a hole structure, the mask type is negative, not positive. So click the zone condition and define the patterning mask as CNT. And then please check the negative option. And the role of the CNT layer is to connect electrically between sustain and active layers. This means that the layers in between should be applied the etching process, which involves unselective etch and etch stopper functions. Once again, I will give you the definition of unselective etch and etch stopper. If unselective etch is used, the etching process starts from that layer. Then, etching proceeds until just before the layer for which the etch stopper is checked. Therefore, unselective etch should be applied to the CNT layer, and for these 3 insulator layers, pores should be created in the form of a CNT mask. Therefore, the etch stopper should be unchecked. So, I will select unselective etch for the CNT layer, and then I will uncheck the etch stopper for this 3 insulator. The next one is SD layer. Just select the patterning mask. The following one is the via hole. If you check the layout, a via mask is also a hole-shaped mask like CNT. Therefore, this mask is negative. Click the zone condition and define the patterning mask as via. And then please check the negative option. Since the role of the via hole is to connect electrically between anode and TFT underneath, unselective etch should be used as well. Additionally, it is a very thick and planarized layer. So, planarization should be set as yes. And to completely planarize, enter the DOP as 1. For gap position, select max so that the planarization option is applied based on the highest position of the bottom layer as D. And then click OK button. The next one is anode layer. Just define the mask. The following one is PDL. The purpose of using the pixel define layer, which is called PDL, is to divide the subpixel area clearly. Therefore, since this layer also uses a negative mask, please check the negative option. And to completely planarize, planarization should be set as yes and enter the DOP as 1. For gap position, select max so that the planarization option is applied based on the highest position of the bottom layer. And for the EL, there is no mask. To planarize completely at the highest position based on the anode layer, at first, planarization should be set as yes and enter the DOP as 1. And then gap position should be set as max. In this time, the reference drawn is anode. So from now on, we define the properties of all layers to be used.